Hello, hello. Hopefully things are working. I know their audio changed this time around. I have an actual mic mount, like a shock mount, so hopefully the computer noise isn't coming through either. I was improvising something with rubber bands before. Yeah, so let's write a hypervisor. I was messing with NVMe earlier, but there's some dependencies for that, so instead, let's go for that. Actually, let me clean up this console. It's too much junk here. And get some... Oh, interesting, did that die? This is new called the consoles. I think I don't have anything that's going to break badly if I... Well, if the audio dies, that's why. Let me just restart it. Yes, I did a system update earlier, and it's probably some things that are a little bit confused with old libraries. Oh, no, this came back. Oh, maybe we're good. Okay, whatever. Then we're good. Cool. Let's see. Let's get some video feed. Difficulty of writing a hypervisor from scratch compared to what I've done with since... I don't know. I mean, it's... When I say hypervisor, I don't mean like KVM or VMware. So... I don't know. It's not... It's... I think it's on the same level as like... the proxy and MMU parts of Mini. Something like that. Like it's not, you know, I'm not writing a VM product. I'm writing a very simple hypervisor, and I already have a chunk of it. Well, I can already run something as a guest on Mini. It's just that it doesn't actually hypervise anything, but it does run in guest mode. So it's basically adding features to that. Though I'm going to kind of start from scratch because that's the way it's done right now is kind of like a hack. So I have this. Basically, this part is this is my hypervisor right now. Okay, it changes two registers, and then it uses this special. Where is the function? Is that in exceptions? Yeah, like this, right? Like it's these two lines of code and this thunk here to put things into guest mode and handle some exceptions in a special way. That's it. This is my hypervisor right now. But I'm going to rewrite this from scratch because it can boot Linux in single CPU mode as a proof of concept, but it's not really the way you would do a real hypervisor. This is more intended to run test code in execution level 1, which is the guest mode, for the purposes of research. But it's not really meant to run an OS as a guest. So I'm going to leave this the way it is and not touch it. Because this kind of assumes that you will return back into Mini and stuff, right? So it can barely boot Linux, but it's not really intended for that. So I'm going to leave this as it is and make a whole new file that's going to have an implementation that's going to be intended to run guest operating systems. What's my opinion on Rust? I like Rust, and I still haven't managed to find the time to learn it properly. So we'll see how that goes. But I like the idea of moving a lot of systems coding to Rust because it's a lot easier to not make stupid exploitable mistakes. Speaking of, this hypervisor is not intended to be secure in any way, shape, or form. So that's another thing that I don't care about. It will very deliberately be possible to take over the hypervisor from the guest, because that's not the point of this hypervisor. Because that makes life a lot easier, right? So there will be no attempt at sort of isolation from the hypervisor. The only thing I'm going to be hypervising is things I need to achieve my goals, which is not security in this case. So just keep that in mind. This is all for research, so it doesn't matter. So let's make some files here. We're gonna need some assembly. That's probably good enough for now. So let's do a bit of copy pasta. This should be at the top. I'll fix that later. Probably won't need tools and types, and eventually SMP. And a header file. So the way this is going to work basically is we're going to have an initialization function to bring things up in hypervisor mode. Or rather, just to initialize the state. So this is all going to be run from Python on the PC, right? And the idea is that Mini is going to implement enough code to make this all perform well, but I can still use Python to implement some hypervisor features. So one of the things that's going to end up happening today, if I have time, is I will add. I needed to have a way of for Mini to report events back to the host, because right now there is no way of reporting events other than like the console. So I'll add something like that. But anyway, basically we need an init, and which is just setting up configuration, and then start will actually switch to hypervisor mode and run the guest. Actually, we can just do an array there. I wonder if we're going to need a context. Yeah, we should have a context array, because eventually we're going to... I'm probably going to end up... well, I don't really need a context array, because I already have the registers and everything else is banked. We'll see, that might change later. So... Ooh. So for now, this is going to be the same as this, just setting up these registers. We don't have the... we don't... Well, let's make these comments. We don't have ARM system register definitions yet. We have the Apple ones. Where was that? CPU regs, I think, yeah, these are the Apple ones. And actually, this should be renamed, because this should be sysimp, because that would end up called in Linux anyway. Yeah, this stuff, right? So it's all sysimp. So let's do that first. Actually, let's do it on all the files. That should do it. Reload? No? Why didn't that work? Worked all there, but why not the file? Oh, is it just because it failed on the... No? Oh, yeah. Oh, we're there, yeah. So let's just add all of that. Do it here. Hopefully none of this is terribly evil. No, this looks good. I should just get rid of that chicken thing. Actually, this is very dead code. That can go away very much. Oh, and we have some proxy client too. Or did we not? Oh no, we didn't have the Apple registers in here. We had the ARM ones, and I think someone added the. I think there was a PR for that. Yeah, we should. I should add that eventually here. Well, I'll take care of that later, so it doesn't matter. Yeah, I think that's the only place it gets used. Wait, didn't we have some in IRQ? Interrupts. Exceptions. Didn't we deal with... Yeah, this. Where does that come from? It's gonna fail, right? Yeah. Oh, there's some sim... No. Why didn't that get replaced? Probably the same reason. Let's do that. Let's see. Yeah, we're missing things there. This makes sense. Yeah. And also, I just noticed that those exception dumps use the prefix for these and not those, so it's just too long. So let's just get rid of the prefixes for the print. One second. Actually, you know what? I think I have a thing. Hold on, I'm gonna put the... Didn't I have the... 1 second. Didn't I have that in artwork? The YouTube stuff? Because I think I just got pinged on IRC and I was going to move to the other screen. Give me a second. Just 1 sec. But where is that? Well, it wasn't social media. Hold on. Hold on, what? Oh, it's not in Git. That's why. That's why. I have 2 different copies of this repo. That's why I got confused. Why do I have 2 copies of this repo? Yeah, sorry. I just saw the IRC thing anyway. Well, what I was going to do is copy this thing. Let's put it somewhere random. Let's put it in the home directory, actually. Because that way I can... that way I can do this, which is a bit better than a black screen whenever I need to switch to something else. Okay, sorry about that. So I just got, and also giving you a second. Yeah, okay, sorry about that. Okay, so back to this. Yeah, that should be fine on the Git now. I think it's formatted. And that it builds. Yep. So... Keeps things consistent. Now, so we have this kboot stuff. Yeah, I'll fix that in a bit. Don't care about that. hv.c, reload. Ooh, this is messy. Okay. I guess it really doesn't like it when I mix Python and... Anyway, all right, so we need to enable the physical time for one. Let me bring up the documentation for ARM. Docs, not here. Vendor docs. ARM. This PDF is so massive it takes time to open. But yeah, the one this one's doing is the countctl thing, which is here. And I should start CPU regs right now only has Apple stuff. And actually, a lot of this should be rewritten to use the bit macros and stuff like that. Yeah. But I'll do that later. I'll just start doing the... I'll just start doing the ARM ones elsewhere. How am I doing those right? I think most of those definitions are in the individual things right now. Yeah, like these. So these should all move here eventually. But for now, let's do it like this. And I can just include that here. And that way we have everything in one file. So, yes. So all of these are, like, the actual registers are defined in, like, in the assembler. So we don't need to define these. But the problem is that I'm going to want to, like, symbolically... like, I want to eventually have a kind of table of registers built out of this stuff, which means that I do want to have the these defines. The annoying thing is that I already have this data in Python anyway, so I'm not gonna care. Well, I'm trying to decide if I want to just generate this from the from the ARM spec, because I already have a parser for that. I don't know if like the bit definitions that they had were useful. Well, let's shave another yak. Asahi git mini. This is in. It's not in mini. Sorry, I don't even have a thing. I should put this in git somewhere, but it's nowhere there right now. So this is in vendor docs. ARM. This thing. And so the thing is, there's this bunch of XMLs that have all the yeah, so for example, what was it? Count HCTL. Should be in here. Yeah. There's all this XML stuff that ARM provides with all the fields, and I don't parse the fields right now. I only parse the register names and definitions, but if I can just add a bit of code to this to generate all that code for me, that will be quite handy. Though I probably don't want to make the whole thing auto-generated, but rather just like use this to generate things I copy and paste into Mini and then still run through the formatter is probably safer, because I don't want to have like the entire, all the registers, only the ones I need. But how sane is this? Field ID, MSB, LSB, and then reserved. I like this capital F false. So it gives me the feeling that they generate this using Python. It's kind of a telltale. So wait. Why is this reserved type 0? Or RW type? Wait, there's no RW type here? Okay, so let's just do the fields here. Do I want this to be a... Nah, it should, I guess it's going to have multi-bit fields. It'll just be an array. And I should actually just call this like... put an index here. So for arrays, we have the nth number of the array, and that way I know the first one is, I can filter for that. So take that, and then fields. Oh, and there's a condition. Oh, that's going to be so annoying. Yeah, because all this stuff varies depending on E2H. Yeah, there's two, of course. Fields instance, yeah. Okay, in that case, this is going to be a map, and then what we do is let's see. What was I doing? Sorry, I just got pinged on IRC. So actually, let me put the windows in a saner thing and see if I can pop out the chat. Yeah, it's better. All right, so we need to find all. Let's call those field sets for fields int find all. For reg find all fields, and then we got instance, like text before fields. Let's see. Okay. So let's call that F. Make that an array. Feed sets instance equals fields, and then for each field, actually, yeah. Fields, so that F and fields find all fields. Mm, and for each field, we need to ignore the reserve. This is the RW type 0, and then it says reserve type reserve. What does that mean? Like, why? Is that because the RW type... Hmm? I'm confused. Why is this? Why is there 2 fields with 16? Oh, because of the feature. Fields condition when feed ECV is implemented. Okay, so in that case, there's going to be some duplicates, but that's okay. So RW type of rest 0 is something to be ignored. Where's the attributes? Well, I'm going to do the text for now. Let's just do everything else. So MSB, LSB. The problem is the value. We don't have a good. I kind of want to steal the bitmask stuff from Linux, but like I can't just literally copy it because that's GPL licensed. So I'm wondering if I want to like re-implement that, or just have bit shifts. Like I do it, yeah, I do it like this with the way I'm doing it in Mini is with functions like this. So I guess I can do the same thing. Either way, so that's fine. MSB, LSB, I need a name for this. Let's skip rest 1 for now. Let's just see how badly this breaks. Uh, hmm. Oh. Dumb. Oh, okay, at least it doesn't break. Okay. And then I can just load the JSON, which is the same thing that is done in utils here. Isn't sure if that worked. Okay. Oh, there's no conditions on those? Hold on, did I mess up the... Oh, I forgot. Hmm. Oh, is there... Did I mess up the... Huh? Maybe that's why it doesn't break, because it's not... Find fields? Well, it should be fields. What's going on here? Register, register. Oh, is it outside that? Oh, it's outside. No, it's not. At least can we get XML that isn't like formatted like hell? Pretty. Is there a pretty print thing here? Yeah, that. Oh, it's inside reg field sets. Okay. That makes sense. And now it's probably going to break because I'm sure something is going to not work here. Yeah, as I expected. So it doesn't have an instance for which one? Yeah. Mm-hmm. Oh, if there's no instances, then that's all of them. Sure. We can use none, right? Probably, yeah. This works these days in Python, right? Wait, hold on. Hmm. Field name. F. Okay, there we go. And then we need, there's no field name for something in AMCFGREL0. And I print, like dump a subset, like 2xmn or something like that. And do that. No. Would be nice to have like, I think to just dump. Anyway, ID 0 that, RD type it is, there's an RAZ, okay. Sure. And then it doesn't have, well, actually it's fields length. So let's say get that. And field name MSB, LSB. Let's put that in the field sets. Well, the width is hopefully the same. Hopefully this never happens. And then if MSB equals -1 and LSB equals 0, then it's the whole register and there's no point in defining subfields, so we can ignore that. Okay, and then there's an unknown thing, RW type unknown. Yeah, sure. Actually, we should use this ID thing. None 310 is what? That stinks of Python so much. So, like, the top is reserved, and then the bottom is... It's so funny. Okay, so in that case... So we can ignore the field if it has no name and it's aligned at the bottom, because then it's probably the whole register. And then I also need to assert that not fields, because nothing else should be in there in that case. That didn't work. What is NCG? Wait, this was working before. Now that has a field name. There we go. RAZWI. Okay. RAOWI. $63.11. Interesting. Oh, yeah, because the bottom bits are... I can't assert that. Okay, fine. So in that case... In that case, I can... just do that. Okay, that worked. Let's see if I can dump the thing. Okay, there we go. Oh, I have a print here somewhere? Yeah. Ooh. Okay, and now we got another nose, which isn't helping. Oh, but that's because the ones without the conditions. Yeah, it's fine. Should probably sort this anyway. Cool. Why is null literally... Is that how it works? Can null not be a... Okay, in that case, this shouldn't be a... It should just be like that. And then not items. Yak shaving. Okay, there we go. Get that. It says fields. The fields. String is integers y for f and field set. No, for f and field set fields. Print f. Yep. Yep, that makes sense. Okay, so in that case, what I want is name equals like name, and then what I do is print define sys name. And the media encoding. How did that work? Enc. I've never put something this ridiculous in a format expression before, but it should work, I think. Yeah, that works. And then actually, don't use this for that, and then just to cool, and then otherwise. For the mask, how was I doing that? At least I'm going to define. Yeah, no, let's do it the Linux way. It's gonna be better in the long term. Keeps everything unified, and that way you can do it exactly the same as I did here, and even copy and paste this stuff. Just gen mask. So in that case, and for the accessors. Let's just re-implement what Linux was doing here, because I like this. We don't have the values, by the way, but at least this field prep is what they called that. Actually, does that exist in any project that is like not GPL? That's the Linux version. And that file is GPL, presumably. Yeah, GPL2 only, so I can't use that. But I like what it does, so I'm going to re-implement the same feature, like a compatible API. Pretty sure a judge just ruled that it's legal, so. Yeah, so gen mask is obvious. Well, this can just go in utils. And the way you do this is bit of MSB minus LSB minus 1 gives you all the bits you need. LSB. I think. Do I need MSB minus plus 1 here? I think I need MSB plus 1 here. Yeah. Yeah, so that one's easy. And then the tricky one is the field prep and it was a field extract too, I think. Get, yes. Field get and field prep. And yeah. Even, yeah, so that should be fine. The API is field value in both cases. So let's do the same API. I'm actually pretty curious how they implement this. So field prep is actually probably pretty easy. As I can just do. I need to do something to get the LSB only. What's the right bit magic to do that? Oh, -1. Yeah. So if I do field and not field -1. So it's a consecutive set of bits. So if I AND it with that -1, I get only the LSB. Is cleared. So if it's inverted, then this will give me only the LSB, and then I can just do value times. And that should actually work. But extract is... Actually, does the compiler know how to do that properly? I could divide. But I don't know if the compiler knows how to do that. How to divide by... It probably does. Because otherwise I need like a log2, like a built-in log2. I don't know if I want to do that. No, I don't know if GCC has that. Hold on. Is it a built-in log2? Probably. But I don't want the count leading zeros. I want the... I want the... Actually, let me open a new Firefox here so I don't have to keep switching desktops. Yeah, there's that. But does that work statically? And Clang should have it. Does it actually know? Let me just try this and see how it works. So if I just go to main and just like... So hopefully at least this works. If I just do %d and like... just give me a flag for where I am. And... get a mask. Field prep, and hopefully that is optimized. But if I do field get, and then in utils h So basically it would be val and field divided by got parentheses everywhere. Let's see. Something is broken. LSB, sorry, not MSB. Not val field LSV is just this, sorry. Okay. And let's look at the assembly for that. Actually, I can save temps it, but whatever. Object dump. Build main. For 42. Was it? Yeah, there. Yeah, it is constant optimizing it. And hopefully that works. 10.5 should be 320. Yeah, that's correct. And then like dead beef is that. And if I do like 5 bits, so 1F. No, 6 bits because it's inclusive. So 3F, 55. Yeah, okay, so it's doing the right math. And now my question is, can it do it at runtime properly? If I do like some random thing like this. Yeah, UBFX. Cool. Let's use it. It's doing exactly what I wanted to do. Okay. And hopefully the opposite one also just does a shift. Didn't it have the F8 on that? Yeah, BFX, and on this one it did just a shift left. Yeah. Yeah, that's okay. Yeah, it works. I don't know how Linux does it, but this is how I'm going to do it. It's like, it feels wrong using multiply and divide, but, you know, like, it works. Oh? Well, that's interesting. It thinks this is a pointer. It thinks that's a pointer dereference. No. That works. Damn Clang format. Because it thinks this is a cast. It's not a cast. Okay, fine. Yeah, okay, cool. So then this should solve my problem, and you can rewrite all the other code later and clean it up to use these primitives. I'm sure Linux has like a giant blob of code to implement this, and it does like compile time checks and a whole bunch of other things, but at least this is going to work for me, so... Cool. Why did I touch this? So generate include, yeah, that should work then if I just do generate include. Where was I? Where was I? Don't need that. Cool. Okay, so let's put these things in a tools directory here. Vendor docs, arm, rect to JSON, and red include. Cool. Proxy client. This shouldn't be here anymore. It should be in build. But not build. It's not build, but... How do I do this? It can be here, to be honest. What was that called here? Just regs? The JSON? Yeah. Proxy utils, and then we can just do an like... That should work. Cool, and we're not gonna have all of them, but at least the ones we need can be just copied and pasted from here, and it's convenient. Also, this end thing doesn't work, obviously. But it's good to have some consistency. So, okay, back to where I was. Hypervisor. Pop the stack. ARM CPU register. So I need this one. Contains CTL EL2. So find that. And then we get all this nice stuff. And just copy and paste it here. And then we can format. And then that's nice and clean. I kind of want to get rid of the EL2. I kind of want to get rid of this. This is too long for bit definitions. Yeah, that's what I thought. It probably has checks for misusing it and stuff. So yeah, I'm going to take the EL2 out of that because it's too long. So basically, EL something. Actually, just do -1 says 2, 3, 4. Do that. That didn't work. Did I forget how Python string indexing works? What? Oh, this is the wrong file. I just moved this. Let's delete this before I get confused again. Yeah, that works. Cool. And format. There we go. We need an include here. And then eventually, I actually just want to stick all these in a JSON file and also generate this the same way, and we can fix all of this. But for now, this works. Okay, so back to the hypervisor. The first thing I need to do is I was setting... oh, this is not sorted. Oh wait, yeah, that. Hold on, something's wrong. It's not printing the instance. There should be two instances here. That's why this is duplicated. Why? Check to JSON. Fields instance. Get that. Oh, HTML, not HTML. Why? That's definitely not working. Rect to JSON. Field sets. All right. That. Yeah, that makes sense. Yeah, so this is always the case for us. So in that case, just do it like that and format. In that case, I need the EL1 physical timer enabled. Then MSR, ACR, IR. Well, we're going to initialize HCR EL2 anyway, so get all that. Not HCR. Right. There's a lot of bits in that register. And I actually kind of want to just set the defaults to everything sane on this one. So let's look at the docs. Actually, I can just see what the current defaults are and kind of use the same thing. So what is this? Bit 3, FMO, IMO, yeah, it has those two. And then, yeah, so we don't need most of those. I want IMO probably. Yeah, I definitely want AMO. All SR interrupts, I want to get all of those. So let's see. And nothing to GG is 0. I think it's fine to have those disabled as soon as we start the hypervisor, but I might want to enable them and then only disable them right before running the guest. Depends on what we're doing. But for now, that's fine. So I definitely want AMO. Then what else is in there? This 8.8. I think that's just this is another one with all the 1, 2, 3, 4, 5, 6, 7, 8. 6 and this is 24. And that should be 20. Yeah, TGE, right? So HCR TGE is necessary to run stuff at EL2, but we're not going to do that in hypervisor mode anymore, so we don't need that. What we do need is E2H. RW is what? Yeah, obviously needs to be RW. And then that RW. Yes, that 4 is E2H, 8, 0, and 2. TEA is what? External abort. Yeah, let's do that. No, wait, that's not right. That's not that bit. It's the previous one. T-air? I think I'm counting bits wrong now. Hold on. 37? Yeah, 37 is so it's TA. Yeah, it is TA. I feel like I'm counting this wrong. Yeah, that's fine. And then we have APK, maybe? Yeah, APK and API are set. And those were traps or registers. Yeah, one is not trapped. So APK and API, we don't want to trap those. So we definitely want those on. API, APK. Yeah, so that's good to get a default on that. And then we will enable VM later when we actually go into... Actually, we can probably enable it now already. Because nothing's running in guest mode anyway. Cool. So we do that, and then we need to start setting up some page tables. The thing is, this is going to be different from the regular page table mapping, because the regular one, we actually hard code all the addresses and everything, and this works without allocation. But for the hypervisor, we need an extra level anyway. And it's going to be very similar, but not the same. And it's going to be dynamically allocated. So, static void. Let's init the page tables, and then we're going to have a I think it's probably the same as stage. I can probably use the same layout for the page tables. Stage 1, probably. Oh, this is annoying. Can I do it like this? Ah. Sure. Well, that works anyway. Let's put it in a thin line. No, that does that anyway. Fine. I need the page tables. Help if I don't do that weird thing there. L0, not L0, L2 probably. No, L0. It is called like that. Okay. So for the translation settings, which we also need that register, I'm wondering if I want to start including the field settings. So I think the physical size was only like 36 bits on these machines. Yeah, I think so. So PS has to be so it should be 36 bits minus 64, so 28. Need to look at the starting level 0, yeah. Starting level 0. What level is it? TG0 is... not 4 KB. I want... Hold on. Okay. It doesn't matter, does it? Non-secure state, yeah. We don't care about that. I don't think we care about any of that. So SL0 is the one I need to get right. This should be fine to set the inner shareable. Let's go through all the bits. So the ones we care about is we got PS, then TG0, SH0. Outer right back. Cache. Should be fine to set it to 1. Right back, reallocate, no right allocate. Yeah. Should be fine to... Should be the same for that one. Then we have a 0. T0 set. Yeah, that's all of it. Okay, so SL0. Okay, so I need to make that consistent. So this is 28. Which means we can actually start at level 2. And 28 to 38, yeah. Cool. So SL0 should be 1. Cool. Just put the closing there. And in that case, how much level 2 do we need? Basically all of it, because it's 28, so that's fine. Actually, everything's going to be dynamically allocated anyway, so and initially everything is unmapped, so that should be fine. And then we do static void HV. And so this is going to be interesting because I'm going to be using these page tables to store both actual page tables for mapping guest pages, but also mapping like when for unmapped pages, I will store like the address of a handler or information for me to be able to handle that page fault. That way I can reuse the same structure, not to have a completely separate thing going on the side. So what I need to do is everything's unmapped initially. Everything hits a page fault. Actually, let's do this pt init. Do like that. Pt init. Let's do it like this. Start size. I don't even know what the attributes do when it's a hypervisor. Probably the same, but let's see. I keep forgetting where the damn page table stuff is. Ah, here. Yeah, so stage 1 and stage 2 is different, right? Because these are the ones they care about. So we don't really care about any of the permission stuff, but contiguous, 52. DBM, 30-bit modifier. We don't care about 30 bits. think we want def.wb because we want the guest to control all the attributes, not... Wait. So that's for normal memory. It's basically the least case. So in principle, I can just have non-shareable for everything. Yeah. In principle, I can just use the weakest thing for my page tables and then basically 1-1 and then right back. Yeah. Oh, thank you. That's what I was looking for. Yeah, so it should just be non-shareable, and that keeps it the same. I'll ship that to us. SH is 8. Not 8, sorry. Oh, yeah. Right, this is 2. This is actually 6, and this is 8, yeah. AEF is access flag, probably. Yeah, we don't care about that. And then the attribute modifier is what? Not modified, so I don't care about that. And T. Don't need that. Yeah, that's basically all we need probably for the page attributes. So I kind of want to get this running to the point where I just boot the same thing I did before in EL1 mode without any vectors, but with translation enabled and make it work. So let's see if I can just identity map all the address space. Yes, I need to get some lunch, but before I get some lunch, let's see if I can just make this magically work. Let's get to encodings. I forget how you set it to do 32 megabyte mappings. Might be able to use that. Oh, it's different anyway, but hold on. So how do I mark it as a block? That's level 3. I need level 1. Yeah, block. Ah, it's bit 1, yeah. Let's map everything. Da-da. Okay, so just do this map and then HVL2. That should be all there is to mapping in blocks. And then if I just do everything, that should initialize the page table. Put a proxy up in here. Just do that. Need to put this in the make file. And see how broken my build is. Need some string.h. MSR. Yes, I did. Sum and v1 equals 0. Okay, getting there. Equals 1 equals... Yeah, actually, this is do... Not 2, sorry, size. And... Okay, let's see if that works. HV init. And then in chain load here, I need to put a proxy thing. People are asking why I'm making a hypervisor. This is a reverse engineering tool so that I can run macOS and investigate how it talks to the hardware. It's not it's not intended as a virtual machine system. It's rather a way of inspecting what macOS does. So it's going to be a very dumb hypervisor, but it's going to be a very low-level hypervisor, which means it's going to be very simple. It's not going to try to virtualize. It's a hypervisor, but it's not a virtual machine. So its only job is to allow me to, in a way, debug macOS. More than debug how macOS uses the hardware. So like kind of like a debugger, but I'm not looking at the macOS code. It's like strace, but for hardware, basically, if that makes sense. It's called Mmiotrace, and it's how like Nouveau reverse engineered the NVIDIA drivers, except they used a kernel module and not a hypervisor because they already had a driver that worked on Linux. But I like this idea better, so I'm doing it with hypervisor. It could, in fact, turn into a debugger, but I don't really want to look at macOS code, so unless I really have to, I probably won't actually be adding like single stepping or anything like that. So let's see if this works. Okay. So if I just do a chain load EL1, and in this case, I'm just going to HV init, need to put it here. And so first let's do it the normal way, just to make sure that I didn't break anything. So if I do chain load EL1, cool. So and running in EL1, yeah, so that works. With the old, I haven't changed anything yet. Why did that UART not work though? it's probably just some junk done there. Yeah, not sure. But anyway, so let's reboot that. And then I can save this instead of doing these things and see what happens. So I need to chain load the update version first. And then let's see what happens if I try to chain load an EL1 with a new thing. It's probably explode. Yeah. I get an exception on some address. Yeah, on the entry point, probably. Actually, no, it's not even the entry point. Oh, that's interesting. Jumping. Oh, no, that's a stub. Sorry. Does this tell me where the entry point is? It doesn't. It'd be nice if it told me. Should make it print that. It's probably the entry point. Oh wait, no, this is dumb. This is doing oh no, this is going to explode. This is yeah, okay, no. This is not the same thing. Okay, let me undo this. The entry point thing is fine, but this is not. This is EL1. This has to go away. This is not going to work like at all. It worked by accident last time, but it's not going to really work. Because then I'm overwriting my own address, and that's a terrible idea. Yeah, okay, no. I'm going to have to abstract some of this out later, but basically it's going to have to be a different file. I'll probably abstract some code, but yeah. It just needs to init that, and then the actual start address is going to have to be new base is not ubase. New base has to be somewhere where I load all my stuff. So I need to allocate some memory for memory size. And then this loads in the Python malloc area, which is probably a good idea for hypervisor mode anyway. Problem is, I don't know where I'm putting it yet until I malloc that. Well, UAS isn't used anywhere. And she gets, yeah, I can probably just change that. So put that in here. Not do that. A new base only. Does not have that. Actually, it's not fist base. Fist base and dirt base can kind of be this. No, it should be. Let's give it starting at EUAs. And divert base is. Yeah, that might actually work. Then. Don't do EL1 for now. And we don't need a stub in this case. And then we do need an IVAU. Don't need a stub. Okay, so we got that. No hypervisor for now, just to make sure I didn't break this. This should be doing the same thing as the old chain load, where it loads after. So if I do chain load, okay, that didn't work. That almost worked. Almost worked, and then it broke where? How'd that happen? Probably something about the boot args is wrong. Oh, the device tree and stuff is going to be in the wrong place, isn't it? His vert base changed. Yeah, that's going to be the issue. Yeah. That probably. And then if I do this, nope. But different though. We got a null pointer here. I got pretty far actually. It failed. Probably because USB is not initialized because the device tree is broken. This is wrong. Oh. No. Okay, at least that makes more sense now. You know, the device tree is obviously broken. Why? U314400, and you're just like, that's not right. need that anyway, but that's not why it's working. Well, let's fix the I/O thing so it doesn't explode if it's not initialized. Which is I think it's not open. Yeah, here. Probably just that. Oh, forgot to build. Okay, and then if I chain run gas, it'll break, but it hopefully won't. Yeah, okay, so at least I can inspect what's going on. Okay, so let's do that again, see what happens with the device tree. Oh, address why it's not correct. So that's where the device tree is, and then if I chain node with that thing, 813B140. Yeah, that's not correct. Once, actually, that's way high in memory. How did that happen? Oh, it needs to be offset by fit space. Right. Def tree is ba.fitspace. Okay, so get the device tree, then set the new fitspace. Device tree is let's do it with that. Should do that, hopefully. Put that in there. Chain load. Okay. So here is regular mode. Still breaks. That is a crazy far. That's not correct. What did I just do wrong here? Oh, overt base. Ah, there we go. Okay, now it works. So this is a EL2, and if I do EL1, okay, that still breaks, but we're getting somewhere. Interestingly, it broke on a PC that is way before where it's supposed to be, which is very interesting. HEFE 6000 FE 74. So it ended up in EL1 in the old. That's interesting. It ended up in EL1 in the middle of the old code. And the stack pointer too. Oh, hold on. This is wrong. Because I need to actually pass it the boot args. No, but it is correct. New base boot args off. Yeah, that is correct. This is just not necessary. Oh, Arndt is mentioning that, yeah, if we can use this also as a GDB stub or as a an early con thing for Linux, that'd be useful too. So definitely. And like I need to keep control of the USB because I plan on using that for all the Mmiotrace stuff because I need the speed. So this all needs to work through USB, and I already have a device tree parser, and I'll like do something to remove the remove that device tree entry so like macOS doesn't know about it. And then for Linux, we can just do it in our own device tree. Or we can have something in Mini that like automatically figures that out. But either way, yeah, that'd be useful. So let's see what broke here. Instruction abort. Yeah, well, I mean, it probably isn't even where it's supposed to be in memory. Unless, where is this anyway? 8158? Build miniF arch. Oh, it's the one thunk. Okay. Okay. So, okay, so it's just a regular instruction abort before we get to the entry point. Which probably means my page tables are wrong. Did I set everything correctly? Oh, wait, I bet the that needs that bit set, doesn't it? VTTBREL2. CMP is what? No. Yeah, okay, so it's just an instruction abort in the stub, which means we're not translating properly. Was there a way of getting what the abort, like what page table info was? ESREL1. So EC is... Well, whatever the instruction report was, but... Instruction abort taking with a lower exception level. Yeah, ISS. IFSC. There we go. And it's A, which is access flag fault level 2. Oh, okay. Do I need to set the access flag to on? Probably. Yeah, I seem to recall we need to do that. Yeah, it needs to flag access, because otherwise it traps so that you set it. Yeah. Hopefully it's the same bit, I think. Bit 10. Yeah. Actually. Put it here. Build that. Chain load. Do EL1. Whoa, that is a loop. S error. Ooh. And it's actually an L2 error. Okay, so I'm translating something wrong because I'm getting a bit. What the hell is that address? Well, that is very interesting. Eight 158, isn't that still? Oh, it's still EL1. Okay, so we're translating wrong, but we're translating. That is quite insane, whatever happened there. Oh, this is not aligned, and yeah, that's yeah, that explains things. Yeah, page tables need to be aligned. That would explain things. Okay. Let's try that again. EL1. Hey! That worked! And yeah, I don't know why that has some garbage there, but yeah, cool, that works. Okay, so I have a VM. As in, I have page tables and stuff. Okay, I need to get some food and get some other stuff done, and then I'll be back to continue with this, because obviously I have a VM, but still no hypervisor. There's no actual handlers, but I'm just translating memories. So the next step is going to be making adding some code to more reasonably handle this block mapping stuff, and then I'll probably refactor this loader a little bit so that it's like the Macho light. This should be in a different file that gets imported, and this needs a bit of cleanup. And then basically I need exception handlers so that I can actually handle when the guest does something interesting, and then I can start unmapping bits of the address space and emulating them, which is what I want to do. And there's going to be a lot more stuff to do, like system register handling. I need a generic read-write thing, which is also going to speed up messing with system registers from Python. There's a lot of little things to add, but actually, this is the most annoying thing to get right, because until the page tables work, the virtual memory stuff works, you don't really know what's wrong other than like that one reason code in the exception handler. So now that this works, I don't think most other things should be very difficult to debug. Cool. Okay, I'll be signing off for now and get some other stuff done. And if I have time later today, probably do another short stream, see if I can get a bit more work in. We'll see. Depends. So thanks, everyone, and see you later.